This Week in Radio Tech, episode 261, is brought to you by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. By the Telos Zip 1, the world's most advanced IP audio codec. And by the full range of Axia X nodes, mic, stereo line, AES, GPIO, and the Combo X node. One-touch simple setup balanced with powerful AOIP connection options. Hey, TV stations are doing it, TV networks are doing it, big corporations and SMBs are doing it. So why aren't radio stations doing it? We're talking about IP connections with remote offices, moving vehicles, concert and sports venues, and just about anywhere you'd want to broadcast from, and do it reliably with bonded wireless data connections. Chris Tobin and Kirk Harnack explore the affordable tech that makes this possible. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack. Glad to be here with you. It's our 261st show. Just every show just amazes me how long we've been doing this, and I'm just delighted to be here and talk with you and talk with Chris Tobin and sometimes guests about broadcast technology, which is turning a lot into IT technology. So it's important that we learn those kind of things, and some of those things will be on our show today. Hey, I'm in Nashville, Tennessee at my office. This is where I spend most of my days, and on the other end with us is Chris Tobin. Chris, it looks like you are in Manhattan, your domicile, and a beautiful day there. Welcome in.
It's a gorgeous day in New York City. Yeah, I think it topped off at around 90 and change. I spent most of the time inside in an air-conditioned transmitter room, so there it was about 68 degrees. So I missed most of the heat of the day. But it's very nice there. There is a nice warm, tempered breeze going by.
We should let the audience know, because we have an audience of engineers who are concerned about audio quality. Normally, Chris's audio quality is pristine. It's amazing, like mine. But today, Skype and Windows just really provided a challenge. And so Chris is having to use a backup audio method. Chris, I suppose that the mic preamp you're actually using cost to manufacture about 4 cents.
Yes, that's probably on a bad day. Yes.
Okay.
I kid you not. I'm using the same laptop, camera, microphone, USB interface for the last, I guess 5 years now. Without fail, I've gone through dozens, as we all know, dozens of Skype updates without fail. Today, I do a Skype update, it fails. And it fails big time. So I'm curious that maybe something has changed in the core, under the hood, beyond the usual stuff. So I'm going to have to do some research. So I apologize for those who may find the audio somewhat difficult to enjoy.
Well, the good news is we can understand you great. The only bad news is there's a little whine in the background that modulates. And so, hey,
that's the HD carriers. That's okay.
Blame it on an HVAC unit on the one floor above you. How about that?
Exactly.
All right. Hey, our show today is brought to you by the folks at Lavo, and we're going to do a commercial for Lavo real quickly, and then we'll jump into it. So hang on through the commercial, because we got some great show and tell items, and I've got a bit of a story. I got a peeve I'm going to tell you about, and the good news is when you get peeved, often you go find a solution. And so I've been working on that today, and in some days prior. And Chris has too. So we're going to get right to that. Hey, Lavo is one of our sponsors, and they bring you this portion of This Week in Radio Tech. And the folks at Lavo, these are clever, clever guys. They've been around for a long time. And Lavo is known for building big audio consoles, the kind that go in remote trucks and TV audio production suites, recording studios, live sound venues like symphony halls. And the folks at Lavo decided a few years ago to make a smaller console for radio broadcasters called the Crystal console. And a lot of folks love it. There's some in the U.S. There's a bunch of them in Europe. There's some in Canada. They're all over the world. Lavo has a big footprint. And now Lavo is making an interesting extension to that console. It's called the Crystal Clear. Not just the Crystal, but the Crystal Clear. And the Crystal Clear console uses the same DSP engine that their proven Crystal console uses. So this DSP engine is a proven design. It's been around a long time. And the DSP engine is a beautiful little one rack unit box. So it slips in easily anywhere. It is available with dual power supplies. It has all of your audio inputs and outputs right there on the back of it. So it's got some mic inputs, line level inputs, line level outputs. It has some AES digital inputs and AES digital outputs, all right on the back of it, all crammed in there. And then it also has some GPIO or some GPO, so you can give yourself some tally light indication when you turn the any of the studio mics on, for example. And in addition to all that, it has an Ethernet connection for a Ravenna network, which is also compatible with AES-67. So you've got AOIP, audio over IP, built right into the crystal clear DSP engine, and it's compatible with the new AES-67 standard. And that means there are things now that it talks to, and there will be a whole lot more that it talks to. Almost anybody, any manufacturer building broadcast audio equipment that has AOIP is going to be building it to the AES-67 standard. So that's the tech part. The other part of the console is a touchscreen, a multi-touch touchscreen. It's beautiful. It's actually, there's a computer running Windows 8, and the console is actually a high reliability, robust app that runs in Windows 8. And when you don't even know it's Windows 8. It's absolutely full screen. It doesn't run in a window. It's absolutely full screen. It looks like a custom app. Well, it is custom for this console. And that's the Crystal part of the Crystal Clear console. It's multi-touch, so you can touch up to 10 places at once, and it totally gets it. It just understands what you want to do. You want to move 3 faders up and down at the same time, plus push a couple buttons, and for me, that would be 5 things. That's about the most I can possibly do. But if you're smart enough to touch 10 things at once, great, you can do that. So it's got faders that go up and down. Even the headphone and the monitor, these are on vertical faders, so you can easily slide up, slide down. It's got buttons on it that are all custom and contextual. That means that if you've got a microphone fader and you touch the options button for the microphone fader, you get microphone options. You don't have to wade through menus that mean nothing to what you're trying to do at any given time. Change the gain on a microphone, adjust the audio processing, change the talkback or the back feed to a hybrid or a codec, for example, all those things. You don't have to mess with stuff that it doesn't need to do. It only shows you the stuff that it's going to do or that it can do for that kind of input. So it's really, it's intuitive. It's very flexible. It'll handle 8 faders, 8 sources on the air at the same time, which is all that most broadcasters actually need. The DSP engine has 24 possible inputs, plus the Ravenna or AES-67 AOIP inputs. So check it out. If this kind of technology interests you, and I think it's just fascinating, check it out on the web. Go to lawo.com and look under products and look for radio consoles, and then look for Crystal Clear. On the page, by the way, that you're being shown right now, you'll find a link to a video. It's Mike Dosh, who's the director of virtual radio projects at Lavo. There's a video there. Just click that video, and it'll take you to Mike explaining how the Crystal Clear console works. Thanks a lot, Lavo, for sponsoring This Week in Radio Tech. And if you want to check it out, Lavo, LAWO.com. All right, here we are with remote possibilities. And Chris Tobin, let me set the stage. And then, I'm sure you've got some comments about this and some practical tips. And then I've got some information that I found out today that I'll pass along to you also. I knew this kind of stuff existed, but I got some good feedback and found some good information today on this notion of bonding wireless carriers. Okay, here's the deal. With my job at Telos, I hear feedback from customers. And late last week, we had a customer who was really lamenting the sunset of ISDN. And, I get that. ISDN, if you're a broadcaster that has a good budget, because ISDN is not cheap anymore. If you got a good budget, you order ISDN, especially if you're in a major metropolitan area. You order ISDN. A few days later, it's put in, and it's supposed to work. I mean, that's your point of demarcation. You bring your ISDN codec, like a Telos Zephyr or any of the other brands of ISDN codecs, and you put in the information provided to you for what's called the SPID, the Service Profile ID. It's like the telephone number. Well, it doesn't have to be, but it's like the telephone number of the ISDN circuit. You put that into your equipment, you plug it in, and you know what? Most of the time, it works. It just works. It works about as well as a POTS phone line. And by work, I mean it's reliable. It has a great dispatch rate, right? Now, hey, I've talked to the support department at Telos and asked them a few months ago, do you still get a lot of support calls for ISDN? And they said, oh my God, we get them every day. I think it's getting worse. Oh, well, okay, that's an interesting information. That's new information. I figured that the telcos and would have ISDN figured out after 25 or 30 years or so, but they still make a lot of mistakes. I think a lot of the brain trust for ISDN technology has retired or been asked to retire. They're gone through attrition. So there's not a lot of ISDN expertise left at many phone companies, perhaps New York, LA, Hollywood, maybe Las Vegas, maybe Chicago, maybe Philadelphia, Seattle. Maybe you've still got some good expertise in those markets, but in a lot of places, you might be talking to somebody 3 states away about your ISDN circuit. Well, okay, that said, so the customer was lamenting that they can't get ISDN anymore, or when they can, it's now instead of a 5-day or a 7-day advance wait period. Now it's up to 21 days or longer. And in fact, I saw an email that came from AT&T, and they were explaining, the new normal is 3 weeks. Well, this didn't suit the broadcaster very well at all, and I get that. But we have other ways of getting audio from a remote broadcast location to the studio, where it typically needs to go. And I realize that engineers have made attempts over the years to get a remote broadcast going with some other method besides ISDN. Maybe they get a cable modem drop from the cable company. They get IP brought into the remote location. Maybe they're using the internet access provided by the venue where they're at. Maybe it's a car dealer or a bar. Or some other entertainment or business venue, and they glom on to that business's internet. And sometimes that is accompanied by not very good results, mostly because you don't have any control over it as the engineer. If they got a crowd of people using Wi-Fi, or as I often say, Marge in the back office is doing a big upload of sales results to Ford Motor Company, well, you may not have the bandwidth that you thought you were going to have. And so your IP remote using other people's bandwidth may not be that good. So I get it. And then there's products out there that let you maybe connect wirelessly. It's still not entirely your bandwidth, but you depending on conditions, you may have a great experience, or you may not have a good experience at all. Here's a box that I have used for a lot of remote broadcast and testing of remote broadcasts. This is a Cradlepoint brand. They call it a travel router. Now, actually, Cradlepoint, I don't think makes this one anymore. Cradlepoint has gone off in the direction of really industrial strength routers. So they cost more. This one was about $150. Cradlepoint used to make travel routers that were in the neighborhood of 80, 90, $100, $110 or so. And they don't make those anymore. They've really gone into a much more robust direction. And that's okay for broadcasters. Now, the Cradlepoint products, to my knowledge, most of them will take one. I think some of them will take 2 either USB sticks or SIM cards. In other words, they have 1 or 2 modems in them, data modems. Or in this case, the modem is actually here in the USB. In some models, you have the modem built in, you have a SIM card that plugs in, and then you attach an external antenna to it to talk to the wireless network. And I don't know about Cradlepoint for sure, but it's my understanding that they don't necessarily offer true bonding of 2 different carriers to give you either an aggregate rate or a duplicative transfer where every packet is duplicated as much as possible on the 2 networks, and then a device back at the studio, back at your radio station, that bonds those back together basically and gives you the packets in order. So anyway, point is, broadcasters have had options like this for some time. Some people might even just take the USB modem, and here's a little bit older one from Verizon, and they have Pantech is a popular model now. This one is not made by Pantech. I forget who this one is made by. And the results that you get are really quite variable. I'm going to ask Chris in just a second about his results, but I have used this in major metropolitan areas and gotten just horrible performance. I've gotten really dial-up kind of speeds in some places. I've gotten a megabit down and half a meg up in some places. Well, if it's consistent, you can do an audio IP remote broadcast with that. If it's not consistent, as sometimes data-starved connections are not consistent, then you're going to have a hard time doing a live broadcast over that. But in other places, get this, in Mound Bayou, Mississippi, that is just about in the middle of nowhere. In Mound Bayou, Mississippi, with this very data modem connected to the very laptop that I'm using right now to talk to you, with that combination, I got a persistent and reliable 20 megabits per second down, 20 megabits per second up. Obviously, nobody else was using the cell site where this was coming from, right? And it was rate limited at 20 megas. But it was, when I did a speed test, straight line, 20 megabits up, 20 megabits down. I could have done HD video from there all day long and not had a problem. Would have been great. Certainly easily do audio, coded audio, especially from there. So, okay, people ask me, okay, what's the benefit of using something like a cradle point modem? Well, if you take this and plug it into your laptop, well, if you've got a really clever laptop, you can get Wi-Fi out of your laptop. But Wi-Fi may or may not be all that useful to you if you want to plug in a wired Ethernet IP connected IP codec. So a cradle point router like this is designed to do exactly this. You plug this in, and it will get, this particular one has a router in the back. You can actually use a wired WAN connection if you just want to use it as a router, or if you want to use wired as the main and wireless as the backup. But then you've got 4 ports right here, and these are, just like any router, this is all configurable to some degree. You could even give data priority to a given port, or a given IP address that you have connected to it, or a given MAC address of a device that you have connected to it. And this box also puts out Wi-Fi. So at a remote broadcast, and you may have seen a video on the Telos YouTube channel. It's a video that we recorded at the Soul Shine Pizza Company here in Nashville, where Lightning 100, a radio station here, does a live remote broadcast, sometimes twice a week there. And they take with them, they actually have a different, they don't have a Verizon, they have a Clearwire modem. And then they use a router that gives them the routing capabilities that they might want, and it gives them Wi-Fi right there. So they have a laptop that's connected to Wi-Fi that goes to the Clearwire modem, and then with that they go using, I don't know, TeamViewer or VNC or one of those things. They go remote control their automation system back at the radio station, and using the wired connection on the back of the router, again via, in their case, the Clearwire, they hook up an IP codec. It happens to be a Telos Zip 1, and they have great remote broadcasts. It's very consistent, maybe in part because Clearwire doesn't have very many customers, and so they usually get a really good data rate through it. So I know I've been talking for a long time here, but I wanted to set the stage about what people tend to be doing now. And then I want to set the stage to mention that a lot of engineers, or at least some engineers out there, have had some poor experiences with either IP codecs, or more likely the IP connection that connects one IP codec to another. And so the impression is, well, that IP codec, especially if you're wireless, that doesn't work very well. That's the impression that they're left with. That it's unreliable. Oh, you might be on the air for a while and then it might stutter, and you don't have a good remote anymore. And hey, here in New York, here in Los Angeles, here in Chicago, here in Philadelphia, here in Atlanta, we can't do remotes like that. We got to have persistently consistent wireless remotes. And you know what? I get that too. Okay. And I realize that if you're using a single carrier box like this one, or a single carrier modem like this one, there's a chance that you'll get starved for data. The network may have various controls on it. You may be at a location that's popular, and a ball game or a race or some kind of event where there's a lot of people there, and just before halftime they start texting and checking their email and looking at scores of other ball games and things like that, and your data rate, if you've ever been to the if you've ever been to the NAB convention, you know how bad the wireless data rate can be. Actually, they've improved it a lot lately, but it used to be just terrible. So I'm setting up for you the problem so that we can then talk about the solution. Let's bring Chris Tobin. I've been yapping and yapping here for 20 minutes. Let's bring you in and tell me the downside of, one carrier operation for doing a wireless internet that's going to get you on the air. What's your opinion?
Well, the downside to any single-threaded connection is that it's single-threaded, and you run the risk of a hiccup in the system. And here's my Cradlepoint router with a Verizon modem card.
Oh yeah, same one. Different. Yeah,
used it since 2011. It's been pretty good actually. It's worked very well. So, but yeah, you can't go anywhere without a Cradlepoint. No, I'm only kidding. But a single connection will work in many cases. I've done it. I've seen it done. You just gotta weigh the risks and benefits. If you can, the thing we have to realize, we have to come to the realization of, is if you're going to break away from ISDN, or we'll call it the switched networks of remote connectivity, and you're going to go into the world of packet switched networks, you need to really sit down and read some books on packet switch technology and understand all the variables that are involved. Because once you get a grasp of that, you could probably make most of your remotes work when you're using a USB modem card or a Wi-Fi connection at some business location or a managed service that you pay for. But we as broadcasters now have to change the way we do business. I mean, I'm just saying that because about a month ago, actually, I did a broadcast using a single modem. It was a Verizon LTE modem into a IP codec device. And for 2.5 hours, we did a straight sports talk show from a bar in the middle of a hockey game, and it worked. It was also being carried on a satellite network, so it wasn't heard just locally, but nationally. And it worked. But part of the reason it worked so well was I put that modem on an extension cable, gaffer taped it to the window above everybody's head, made sure it had the best clear shot outside, and signal strength, I measured it because I used the application on my laptop to read the signal strength indicators. And as a result, I found the best spot, and it worked, oddly enough. And most folks looked at me and said, that can't be. I can't believe it's working. It did. So if you understand the mechanics and look to do this kind of effort, I suspect you'll have a better chance at making remotes happen and not take the first impression of that particular product was the problem and not the actual link itself. Because I can honestly say, and I know Kirk can, but he's biased because he's employed by somebody. I can honestly say that I'm not employed by anybody that makes anything. All the codecs on the market do work with those modems. The trick is the link. That's what you have to work on. So just to clear the slate to make sure you don't walk away with, oh, that particular brand is BS. It's not true. I have used I've used all of them, and they all do work. So I can say that.
Okay, and I agree. But you'd agree with me that you don't always know what you're going to get. It's kind of like a box of chocolates, right? You may have been to a venue over and over again, and you've gotten a great 4G signal, and it's been good. But you go there one time, and something's wrong. Maybe there's something big going on down the street, and that cell site's loaded up. Maybe there's something wrong with the cell site, or with their own backhaul to the cell site, or the fiber or something that goes to that cell site. Point is, there could be something that keeps you from getting the data rate that you were expecting, and then the remote doesn't happen. And that's how this do-it-yourself IP is different from ISDN. We used to pay for ISDN, and we'd get a guaranteed rate. It actually wasn't very good, but we'd get a guaranteed, 128 kilobits per second out of 2B channels, and it was there. And actually in most places, it was tariffed. So you were actually guaranteed that by law. If the telco provided the ISDN line, then it had to work according to these specs. And if it didn't, it wasn't the engineer's fault. The engineer would call the phone company and say, fix this, make it work. And the trouble fell back on the phone company with that. Am I on track there with what I'm saying?
Yes, absolutely. That's why today, in the world of IP or packet switch technologies, aggregating packets for bandwidth has been around for a long time. Broadcasters are now just starting to hear about it. You may see it in video a lot on TV news, but radio has not really jumped on the bandwagon. But you're absolutely right. I'm not saying that you should be able to walk up ad hoc this very moment down the street here in Manhattan and take your wireless device, go to a local pub or retail outlet and say, I'm going to do a broadcast and expect stellar results without some forethought. That's not going to happen.
And the
Breaking
good
news
news is,
events.
well, you know,
I'm
you
sorry.
couldn't do that with ISDN either, because ISDN took days to get installed.
That's absolutely true. So I'm just trying to say that let's not assume that wireless is a panacea for success and it trumps what ISDN gave us for the last 30 years. It doesn't. It's a whole new approach. It requires new thinking, and there's still going to be a little black magic. That's the way it works. That's broadcasting. That's what it's all about. But as Kirk pointed out, the aggregation of packets is something to think about, and that's where there's a chance for the next evolutionary step.
So what I want to set us up with now, before we go to commercial, is this. A lot of you, a lot of viewers here who may follow me on Facebook, you're my friend on Facebook, you may have noticed that this week I'm filling in doing the weather on the Fox TV station here in Nashville. And I appreciate the opportunity to do that. I'm getting up at 1:30 in the morning to go do that, and then back here in the office about 9:30 in the morning after the morning show is over. And here's what I've noticed. I've noticed that this TV station, Fox 17, is doing a lot of live video remote broadcasts during the morning show. The morning show is 4.5 hours long. Starts at 4:30 a.m., goes till 9 a.m. Because it's a Fox affiliate, they don't have, a national morning show to go to, so they do 4.5 hours of live local news and weather and traffic. And so they have, at every single morning, they've got 2 remote trucks out with reporters, finding cats in trees, or where there's a fire or a shooting last night or a burglary or traffic conditions. Point is, they've got 2 trucks out all the time during the morning show, and they have several more they can send out if it's a heavy news day. What I noticed is that every time they do a live remote, the picture is fantastic. The video and audio are terrific. And I thought, are they doing all... I mean, ENG gear is expensive, and I didn't think Fox 17 actually had that much microwave ENG gear. Plus, they're doing HD video remotes while they're driving 70 miles an hour on one of the many interstate highways around Nashville. I think, well, they're not doing that with ENG. They're not doing that with satellite either. How are they doing that? Is that one of those, Live View, or maybe a Comrex box, or TerraDeck, or one of the others? So I went and talked to the chief photog there, and I said, what are you guys using? He said, well, we're using Live View. So I thought you guys got Live View several years ago, and you had some issues with it. Well, we did, but they're working really well now. So the Live View pack, and the ones that they have, they have several different styles. They got a lot of the backpack styles. Then they have a few that are permanently mounted in the trucks with antennas on the roof. But these use multiple antennas connected to multiple data carriers. T-Mobile, Verizon, AT&T, or Sprint. I don't know about. Maybe they're on that too. And they are able to bond these channels together to get upwards of 8 megabits per second of coded video from a moving vehicle, or from the scene of a shooting, or from way out in the county somewhere where a car's run off the road into a bridge abutment. And they're able to do this really reliably. And I'm thinking, my golly, if TV can do this with 8 megabits per second using the same cellular network, that I'm using with my phone, surely radio can do this too. So to my knowledge, there are various products that are made specifically for television. Live View is probably one of the more popular ones. I'm sure I know there are others. And so they've gotten, there's a lot of money in TV, and they've gotten this, a lot of value in having this capability. In radio, it's a smaller market, not as much money, but it turns out there are solutions that radio can use too. And they're not that expensive. And it turns out they are really reliable because they use several carriers to get the data through. And tell you what, we're going to get into it after the commercial. Chris, do you have any quick comments before we go to break on my excitement over seeing this done consistently now in television? There's got to be a way we can use this tech in radio.
Oh, absolutely. Absolutely can be done in radio. Just remember what I said earlier about learning the technology. Packet switch networks are designed to look for the best possible route. So the little packets go along that wire, flow in the LAN, the WAN, or the MPLS and trying their way to go across many different pathways to get to a destination. The technology that Kirk just spoke about does the same thing with multiple cellular carriers. So those little packets leave those antennas, all 8 or 12, find their way to the various different networks, and then find their way back to their destination. They do it wirelessly. So understand the technology, and you'll understand the excitement that Kirk has got about live view in this particular case.
So I should point out, live view, at least the ones that they have at our Fox affiliate here, they're about $18,000 per pack, per setup. So I mean, Fox 17 here has got, over $100,000 worth of live views. A lot of radio stations I know of can't afford that, especially the stations that I own. But there are alternatives, and one of the alternatives is really interesting. We'll get into that. Hey, our show is brought to you in part. By the way, you're listening or watching This Week in Radio Tech with Kirk Harnack and Chris Tobin along. And our show is brought to you in part by Telos and the Telos Zip 1. Well, doesn't that dovetail nicely? The Zip 1 IP broadcast codec. And I'm going to reposition my camera here while you're looking at the web page. By the way, the web page has got a ton of information and links to videos as well. If you go to telosalliance.com and look under Telos for the for IP broadcast codecs, and you'll find the Zip 1 IP broadcast codec there. And its job is to make it easy and reliable to send and receive audio over IP. And that IP connection can be, here, let me get the camera set up here. Oh, we've gone into the screensaver mode. This is one of my Zip 1s, and right now it's connected via public internet to one of my radio stations. Looks like I'm not sending it any audio, actually, but it is receiving audio. In fact, it's receiving audio at 256 kilobits per second because I was doing some audio quality testing on another link and listen. And this is going on in Mississippi, and I'm in Tennessee, in Nashville, listening to the quality of that other link. So I'm actually using this link to listen to the reliability and quality of that other link. So there's my Zip 1. Here we go. We'll put the camera back up here. Sorry about all the bumping around there. And so the Zip 1 is an IP codec, and it's, again, designed to be easy to use, trouble-free, and reliable. It's also designed to always try to get the minimum latency round trip. And that's one of the key features that it does. Hey, any dumb IP codec can work if you set the buffering high enough and the bit rate low enough. And that's one of the frustrating things about using an IP connection. And Chris was talking about, you need to learn about the how IP connections are provisioned and how they work, and what impairments that you can get. And one of the impairments is lost packets, reduced bandwidth, higher latency, more dropped packets between point A and point B. And the Zip 1 is able to actually accommodate all of those conditions automatically. Now, yes, you can manually set it for a given amount of buffering, a given amount of latency, and a given bit rate. Of course, you can set those things manually and they'll be fixed. But you can also use the automatic mode, where within a given algorithm's capabilities, it gives you the highest possible bit rate and the lowest possible latency. And guess what? If the bandwidth available becomes less than it can than you need, the bit rate ratchets down automatically. You don't have to touch it. And if we find that we're losing too many packets or they're coming in out of order, the receive end can automatically increase the buffer time. It does this almost seamlessly. I'm not saying you can't hear it, but it's amazing how well this works in real conditions. So if you're out in a challenging situation, maybe you're using somebody else's Wi-Fi or somebody else's internet connection, and you have no control about the other use of that, well, the Zip 1 takes care of that automatically. And it's really, really cool the way it works. People are using the Zip 1 for STLs, for broadcast remotes. They're using it for monitoring of remote sites like I am here. There's a lot of uses you can come up with for the Zip 1. So check it out on the website of Telos, telosalliance.com, and look for Telos and the Zip 1 IP broadcast codec. By the way, if you're wondering what one of these things costs, to give you an idea, they cost less than half of what Telos's ISDN codec used to cost. Well under half of what an ISDN codec costs nowadays. So if you think, well, I'm not so sure about IP, maybe I'll get 2 of these at each end. In case I lose one IP connection, I can use the other one. The cost has come down so much that these are really quite affordable. So check it out online, telosalliance.com. Now, all right, let's get into this this notion of having more than one way to get IP from one place to another. So one of the problems that we've discussed here is if you've got one telephone carrier, one data provider, providing your connection from a remote broadcast site, I keep using that as an example, it's the most common one, back to the studio, you're totally dependent on that one carrier. But at any given location, in most metropolitan areas and even in a lot of rural areas, you've got signal from more than one carrier. And, with the expansion of 4G LTE, I mean, Verizon is going completely with, voice over LTE. I've noticed that on my recent travels, my carrier of choice is T-Mobile. And my goodness, T-Mobile now has 4G LTE services in all kinds of places they didn't used to. Even on Highway 61, the Blues Highway, going down from Memphis, Tennessee through rural Mississippi down to my radio stations. It used to be no man's land for data for years. And just in the last 6 months, man, it's 4G almost all the way. There's a few miles where you don't get it. But in so many places now, you get 4G LTE. The carriers are having to build this out, and they're doing it to meet demand. Well, okay, so here's the point. What if you could have a device that you're on location on remote, you've got a box that you wire your IP codec into this box, and this box has several 4G or even 3G data modems on it or embedded in it. Either way, you can use external ones like what Chris and I were showing you here with these, or you can use a kind that has the modem built in. You just put a SIM card in and an antenna on the outside, and you get that connection. Well, such boxes are made. Duh, of course. I didn't realize all the choices that you have now. There's one that I found, and let's see if Suncast can pop up the link that I mentioned to him. Let's see, not the first link, but the second link, if you would, Suncast. This is the one, peplink.com. There's different people that make these kind of multi-carrier routers. There we go. This is, but I found one recently called Peplink. And one of their products is the Max Multicellular Router. I guess that's a good name for it, a multicellular router. This particular one that's got the 4 gold antenna connections, those SMA connections, 2 on the left, 2 on the right, that particular one is the PepWave mobile router. Now, I'm not here to sell you these routers. I just found this company, and they're pretty cool. This is what you use out in the field. Now, they also have some slightly more mobile versions. They have some that actually only use up to 2 carriers. This one, I think, uses up to 4. And by the way, you can have 2 modems for the same carrier. So that can help you in different ways, too. But these are available out here. We're going to end up doing a write-up on the TELUS website about some of these products available off the shelf that you can configure, you can install yourself, and you can take these yourself to remote sites. Well, so what's happening is you connect your IP, whatever your LAN is at the remote site. It's probably just one device, probably your IP codec, although you might have a laptop hooked in there too. You hook it to the WAN port on this thing, and then you configure it to send this out over the data modems. And there's 2 ways to do this. Chris, I found this pretty interesting because I asked this question. By using, let's say I'm going to use 4. I'll go hog wild here and use 4 data modems. Let's say I'm using 2 on Verizon, 1 on AT&T, and 1 on T-Mobile. And yes, I'm paying for 4 data plans, but you know what? This works, so it's okay. So I got 4 of them here. Do I get 4 times the throughput, or do I get 4 times the reliability? In other words, does it aggregate these things? And let's say just to make the math easy, let's say each one has 5 megabits down and 1 megabit up. Does that give me a total of 20 megabits down and 4 megabits up? Or does that give me 5 megabits down that's super duper reliable because it's all duplicated, and 4 megabits up because it's super duper reliable and all dedicated? Which way is it? And the answer is, at least with a product like this one, it's yes, it's whichever you want. You can use these things to make your speed higher, or you can use these things as parallel connections to make your data more reliable. And so at the other end, you've got a device, and this is cool. I'm going to get to this in a minute. Let's say at your radio station, you've got a box that is kind of similar to this. It's a multi-WAN router that also does balancing. They call it balancing. It's of course it also does it does the bonding. It takes these incoming IP streams that are now on the internet because they got to the carrier, right? They got from your remote site over, let's say, 4 data modems to 3 different carriers in our example, and then they went through the public internet to get to the IP address or addresses of our router. And this balancing router, also available from PepLink, grabs these streams and reassembles them. Now, if you're using the reliable mode where each stream is sending identical data, it's just throwing out a whole lot of data because you don't need it because it got there. But if it's not there from the one stream it's looking at, it'll find it from other streams. Or if you're doing the high speed version, then it's going to disassemble these various packets back into one stream that's the speed of all the others put together. Okay. That device goes at your station. You put it into your network, and you point your IP codec at it, and life is good. You've got good data. Well, that's all well and good, but they have an interesting service. Instead of buying this multi-WAN router, which a couple $1,000s, instead of buying a multi-WAN router that does all this bonding and balancing, now there's a service available that does this for you in the cloud. How about that? And I found this today. I'm really excited about it. Again, I'm not selling this. I just think it's a great technology. It's called simplybonding.com. And if you want to go there and have a look at their website, simplybonding.com, what they do, and there's a video there on the homepage of that website, they put a virtual balancing bonding router in the cloud. And you just pay them a monthly fee. I think this is the only company doing this right now. Probably others will follow along. In this case, you pay roughly $100 a month for X amount of bandwidth, but unlimited data. So you could run remotes 24 hours a day. And so with this Simply Bonding cloud service, that cloud server, router, modem, all that in one. Well, not a modem. It's hooked to the internet. So it grabs these data streams from the different carriers that contain your data, assembles them all into one stream, and then reliably sends that back to you at your radio station to hook your IP modem, your IP codec to. So you can buy the equipment to go at your studio, and by the way, it can connect to one ISP or several. Doesn't matter, depending on how much reliability that you want to pay for. If you've already got 2 ISPs coming into your station, well, you might as well hook it to both of them. Or you can do this cloud-based thing. Chris, I was really excited when I heard about this cloud-based thing. It just seemed like an easy way to go, pay a monthly fee, get this done, and end up with really reliable remote broadcasts.
Absolutely. Yeah, I read about that last night. I found the same links you did. It's an interesting product, and I looked at it last night, thought about it. I was talking to a friend of mine this morning about some broadcast stuff he wanted to do, and I said, you'd spend a couple of grand on a Cisco switch or a router if you needed it for your business. Maybe it's worth the couple of grand for the balancer unit at your studio if you need to, or you do the cloud service if you don't have that many remotes, or you sit down and put together a business plan, say, if this technology can allow me the equivalent to what I became accustomed to with ISDN without the the delay in installation, then maybe it's worth the investment, either the cloud approach or hardware on both ends, so that I can control the coming and goings. And then you can go places and do things, just like you were watching your TV crew do the Fox video. Now the radio could do the same thing and know that they can grab their kit, go, and be up and running in a shorter time than 3 business weeks for ISDN.
Yeah. And so I'm thinking about the economics here. Okay, so let's say you've already got an IP codec, and maybe you've been disappointed in how it works in some locations, or with a simple cradle point modem, because you didn't have control and you didn't have multiple paths, right? Well, so let's say you've already got that, but let's say you want to add this kind of bonded multi-carrier IP throughput. Well, you buy the box, and there are other brands besides this one. I just thought that PepLink was pretty cool, and then they were nice to talk to. you buy that. They have them anywhere from $600 for a cheapy one that uses plug-in. It's a plastic box that uses plug-in modems like this, or they have them upwards of a couple $1,000 that have a lot more features, and they're embedded radios, and you get your SIM card from your carrier, or your SIM cards from your carriers. So you buy that box, and then you pay the monthly, of course, for the data plans. And could be quite variable as to what you end up paying for that. Let's say that you buy 3 data plans at $70 a month each. Should give you a good amount of data. $210 a month for the data. You pay for the if you want to buy the service, the Simply Bonding service, that's about $100 a month. So for $310 a month for services, plus the cost of the device you take out in the field, you've got, honestly, a really reliable IP connection from anywhere in your service area where there is coverage of at least one carrier. And, nowadays, look, I know it's not everywhere. You may live in West Undershirt, Arkansas, and there's just, hardly any service available. But I got to warn you, engineers, or encourage you, I should say, not warn. If you've been disappointed with cellular coverage and data coverage in certain locales in the past, go check it out again, because it may have gotten a whole lot better. Hey, 5 years ago, there was no Verizon 4G LTE in Mound Bayou, Mississippi, and now there's 20 megabits up and down all day long. There wasn't 4G LTE from T-Mobile along U.S. Highway 61 through rural Mississippi, near Tunica and all the poor parts of Mississippi there, and now there is. So, and I would imagine AT&T is probably doing pretty well too in that regard, since they all promise the largest coverage area between Verizon and AT&T. If you haven't checked it out lately, check it out, and I'll bet you'll be pleasantly surprised at what's available. And so you use a product like one of these bonding deals, and you can get wire-like speeds and wire-like reliability in a lot of places. So you can go do remote broadcasts. Am I?
Well, what was the number you said? How much was the cost, the investment? 600, you said?
They have a box that's 600. Honestly, they said, look, it's a plastic box. You can plug your USB modems into it.
Go. That's their low end one.
Yeah, that's their low end box. And they actually have a cheaper version of it, but it doesn't do the bonding. You want the $600 version of it. And then they have more expensive boxes, like we showed a few minutes ago, and that's on the order of, I think they have one in the mid-teens, like $1,500, $1,600. But I think the model they really want you to go with is about $2,200 list or street price, and it's metal case, SMA connectors for the antennas. In other words, it's going to live with you for years to come, and it's going to work really well. Now you can buy the balancing router to go at your own facility if you want to, or you could pay monthly for the Simply Bonding Cloud balancing router service. You could go either way there. But instead of paying for a ISDN here, ISDN there, DSL here, DSL there, or what some stations have done is they've bought several cell phones for the engineering department on different carriers, and they use the Wi-Fi capability, hotspot capability, and they do that. And yes, that gives you multi-carrier options, but not simultaneously. So you don't get the packet by packet, when you do that kind of thing. So,
well, yeah, Chris, I was just getting at that the remotes that I've done and the amount of ISDN dollars we spent in 1 month time at a radio station I worked at on a monthly basis. We would average about 8 or 9 ISDN remotes at around, I guess $800 per installation, because that was the tariff. So when you do the math, that investment for the teens box with the SMA antennas, the nice little robust ability to keep things connected, would have paid for itself in 1 month. So I encourage everyone to take a look at the technologies, and this is one of many companies, and really think hard and long how you do your stuff, and do the math and the costs and the cost and benefits. You're not talking 14 business days before you get an installation. You're not talking, okay, if it doesn't work, now what do? I got to wait for a guy to come out and check the circuit because somebody pulled down the pole in the backyard. Put all those things on a piece of paper and the pros and cons, and go, wow. So for $2,200, I get a box that lets me do 4 antennas for MIMO and maybe something else, and it pays for itself in a couple of months. It may be worth doing. Maybe do the cloud approach. The dollars make sense. If it's $100 a month for the service, a couple $100 for the box to plug into the service, you're still ahead of the game. So I think this is a great time. This is a perfect time to start having some fun with this.
And I believe part of the point that I've always wanted to make, and it's it's tough. I mean, we all hate it when something that we've relied upon goes away, namely ISDN, and we're uncomfortable in trying new things because oftentimes the first time we try those new things don't work. And it may be that when they started announcing ISDN going away, hey, I mean, in years past, I've had trouble with IP remotes. IP is certainly not been perfect. It's not perfect now, but it's getting better. And the technologies that work with it are also getting better. They're getting better all the time. And here's the absolute bald-faced truth is that you got to do this. You don't have a choice. ISDN will not be here, and you've got to understand and learn how to use IP technology over a variety of different methodologies and paths and transmission means to keep providing the services you need to provide for your client, your broadcaster, if you're an engineer. So we got to do this, and I'm just delighted that there are now better and better tools. And by the way, these tools, I mean, these guys at Peplink, and there's also a company I talked to today. It's called 3gstore.com. Seems like an outdated name nowadays, but that's what these guys do. 3gstore.com. They can name off one client after another, broadcasters, television networks that are using boxes like these or these boxes themselves and wireless carriers to do all kinds of national broadcasts. Folks, and maybe it's just me that's behind the curve or has been, but there's television broadcasters using this stuff every day. And we radio guys, if we're not on the stick already, we need to get there because we can provide some really exciting possibilities to broadcasters who want to go out and do remotes from anywhere. So,
well, I have to say, I was on a panel 2 years ago. Yes, it was 2 years ago. And I was talking to one of the technologists at BBC, and they were talking about their new approach to remote or outside broadcasts and the OB vans they were building and the vehicles they were deploying, both cars and vans. And they were doing something they had a name for it. I can't think of it now. But basically what they were doing is what we were just talking about for the last 20 minutes. This was 2.5 years ago. They were just announcing it, which means they were probably actually deploying it and testing it years earlier. So the BBC, I know, is a client of a couple of these products. I can't say which ones because I remember the guy talking about how they were very secretive about it. But know that the BBC has got a model that when their folks go out to the field, picture an OB van pulling up to an event, whether it be news, sports, or music or entertainment, and they immediately build their own hotspot, and then they have various pathways back to broadcast operations. Okay, they've been doing this now for over 4 years. So think about it. So it's already being done by some small broadcast operation in the UK. But other than that, it's great. Also remember this. Failure is something you should embrace and encourage yourself to do. Don't panic, because even if you do it 1,000 times, which there was a guy who did that, he created a light bulb. That's okay.
Yeah, that's right.
Yeah. 1,000 times. We all benefit from it. Yeah. So just keep that in mind. And Kirk knows I've done some crazy stuff and I've failed miserably at it. But in the end, some of the stuff we did, things that came out worked. So, why not? But if you're not, unless you're talking life safety, you don't want failure as an option, or placing astronauts into space. But other than that, definitely try this stuff out. It's really cool what you can do.
So we're going to follow up on this subject. Hey, if any of you listeners or viewers either are using this kind of bonding technology now, and yes, I realize there's wired bonded technology. Some of the IP codec manufacturers do that. I get that. I'm talking about wireless carrier, so you can go anywhere, anytime, and have at least one carrier, and maybe 2 and 3 and 4 carriers at the same time. So that's what I'm talking about. If any of you are doing this, you want to send me an email or a phone call or something, or contact us through the thisweekinradiotech.com website. I'd love to hear from you. We're going to try to find a way to test this stuff out ourselves and give you some feedback on that with some of the brands that we've talked about here. So I want to be back with you with a report. Also, I do have an engineer, Kevin Pfeiffer, has agreed to come on the show and talk to us about this in a few weeks. So we'll get an update. We'll get some more specifics, and I'm excited about this kind of technology feel like I'm behind the curve on it, but I'm excited about it. And man, we need to embrace this kind of stuff because it's a real solution. Hey, we got one more little short segment coming up. I got a couple of show and tell items for you. But first, this part of This Week in Radio Tech has been brought to you by Axia and the Axia X Node. Now, here's what's kind of cool about the X Node. I just put to use an X Node in back to Mountain Bayou, Mississippi. I just installed a wireless 5 gigahertz link, an IP radio link. Now, it's working. I haven't got everything tied down yet, but actually that's what I'm listening to right here. Whoops, hang on a second. Now, I realize we're going through Skype here. I'm not asking you to listen for audio quality, just the fact that it's here. Again, I'm not exactly asking you to evaluate the audio quality. Let me assure you that it's fabulous. But what you just heard right there, is audio from an audio console on a radio station in Cleveland, Mississippi, then going into, actually, it's in the Axia Livewire domain. That network, that Axia network, goes up a tower to a Ubiquity IP radio. From there, it shoots 6 miles to Mountain Bayou, Mississippi, to another Ubiquity IP radio. And from there, it comes down the tower and into one of these devices, an X node that was just on your screen a minute ago. And that X node is providing at the transmitter site linear, not compressed, but linear audio. It's 48 kilohertz sampled, 16 bits bit depth. I could crank it up to 24 bits, but I've got it at 16 bit depth. So it's better than CD quality because it's higher sampling rate. And it's absolutely linear, being delivered to the transmitter site. Now, I don't have the audio processor hooked up yet. That's coming next trip. And we got a new transmitter to put on the air there. My point is that this X node makes this possible. It's not a codec, but it is capable of doing several different linear stream types. We happen to be using Livewire right now, but the X node is the only product in the world that right now will do Livewire, Ravenna, and AES-67. So I could use any of those stream types. Oh, it also just does plain unicast PCM streams. So you actually have 4 different stream types that are possible to go between, in this case, between 2 sites. So it's just amazing that we're actually delivering that kind of high-quality audio to the transmitter site through an IP radio system that, frankly, the IP radio system was really cheap. And the X node, if you think about it for a minute, think about the X node as each X node has 4 stereo inputs and 4 stereo outputs. If you've got the bandwidth, that X node replaces every codec you might have needed to get audio from a studio to a transmitter site, if you've got the bandwidth. And so you can get 4 stereo streams there and 4 stereo streams back. And what does an X node cost? It's like well under $2,000. I think it's under $1,800 and that's at each end. Okay, so you got to buy 2 of them. But if you're already Livewire at one end, then you only need to buy 1 X node. And that's what I'm looking at. The beauty of saving this money, spending under $1,800 and getting as many as 4 stereo programs there and bringing 4 back if I want to. So it's just amazing. The value is just incredible. The X node is available in a number of different configurations. There's 4 analog ins and outs, stereo analogs. Those can also be, by the way, 8 mono in, 8 mono out, or any combination between those, 4 stereo to 8 mono. There's also an AES version of the node. So it's got 4 AES out and 4 AES digital in. There is a combo node that has a little bit of everything. It's got a microphone input, it's got some analog inputs and outputs, and it's got an AES input and output, plus some GPIO. And there's a GPIO node as well. Just gives you contact closures from end to end. So lots of utility is available there. Oh, and if you're in the TV business, there's now an SDI node. SDI audio video in, it's a de-embedder, it's a Livewire node, and it's a re-embedder with delay for the video to make up for any delays in your audio path. Just amazing stuff. And my goodness, what a value. Most of the X nodes, by the way, are available to be powered by 2 different power sources, built-in shore power or AC, or also power over Ethernet. So, man, this is really a hot potato product. I know the folks at Axia ship a ton of these every month. And probably not at liberty to tell you how many, but it would just surprise you. And it does so many cool things, just like the STL application I just mentioned. So check it out on the web at telosalliance.com, and then go to Axia and click on X nodes. A lot of stuff that they can do. Just put your mind to it. All right, last couple of minutes before we have to go. Chris, did you bring anything for show and tell? Were you able to grab anything?
I actually have 2 things. Yes, actually 3.
Oh, yeah. Go ahead.
Cool.
Go right ahead with one.
Okay. Well, first of all, we were talking about the bonding and crazy stuff you could do with cellular devices and who knows what. So I just happened to bring with me my little cellular SMA antenna that is very handy. It's got 3 dB of gain. And this particular one is from 1700 megahertz to 2500, so it'll cover most of the carriers except Verizon, which is on 700 megs. But it actually, believe it or not, I did a check on it with a network analyzer. It actually does resonate well at about 2 dB, 2.5 dB at 700 megs. So actually, you could use it. It's not a bad thing.
Okay.
And now with the season upon us being so warm and great, and tower sites and transmitter facilities are so well maintained environmentally most of the time, let's not forget our IR thermometer.
Oh, yeah.
I used this today to check a few transmission lines on the outside of a tower section, and very handy. It was pretty cool to find out the tower sections themselves were hotter than the what do you call it? The transmission line.
Wow. Now, how do you aim that thing? Does it have a little laser pointer on it?
Yes, it does.
Okay.
It has a laser pointer, so if you look carefully.
Yeah. Now, the real expensive ones have a little
camera. There you go.
Yeah. Now, don't the real expensive ones have
degrees. I'm running
have a little video screen on them that you can see what you're looking at? But a cheaper one like that one, you just point and it tells you the temperature where the dot is. Right?
LCD. Yep.
A little LCD. Yeah. Yeah. Okay.
It'll hold it. Peak hold. It does it in centigrade as well. And then I got my hands on a TDR recently to do some measurement for a friend of mine. They still use land mobile gear for their IFBs and whatnot. So I found a friend of mine, an engineering company. Let me borrow his. They have several of them, but this is a portable they use for in their field. And I thought it was pretty cool. And it does TDR work, so you can actually check the impedance of a cable, the length, if there's a short, or if there's any troubles on the line, and it's pretty cool.
Wow.
It's handy, so you can actually carry it with you outside and up a tower and around the area. Whereas if you're using an HP or an Agilent network analyzer, they're not really designed for carrying around that well.
Yeah, I've never seen a handheld TDR.
Yeah,
I've never seen a handheld TDR. That's amazing. Good
yeah,
job.
this is one of many, but this is an older model. But it works great. For the few things I have to do this week, this is ideal. That's
so I brought 2 items for show and tell. If you're, sometimes it's just me that's just behind the times. So about a year ago in my house, I put a more robust Wi-Fi hotspot. Well, how many of us depend on the Wi-Fi hotspot that's built into the cheap router to cover the house, and they just crap out after time. They're just so frustrating. So I know you can spend a lot of money on them for some Cisco brand or some other good ones. Here's one from Unify. There we go. I'm sorry, it's the Unify from Ubiquiti, and this is the one I'm configuring for Samoa. Here in the house, I've got actually 2. I've got one from Ingenious, and I liked it pretty well. But I started having trouble. I thought it was with the Ingenious, not sure that it was. So I bought another. I bought a Ubiquiti Unify, and so now I've got 2 of these, and they're great performance out of them. So if you've been struggling with, home style Wi-Fi hotspots, stop that. Go spend 60, 70, 80, 90, $100 on a real hotspot. You'll get much better coverage. You get a lot of options. I mean, you got multiple VLANs, and you can do guest networks and just all kinds of stuff with a better hotspot. And I know a lot of you viewers are well into IT and you know all about these, and that's fine. I get it. I'm behind the curve a lot of times. And I should have pointed out, Ubiquiti and some other brands, instead of using 48 volts PoE, which I always thought was the standard, a lot of them use 24 volts PoE, and Ubiquiti is one of those companies that uses 24 volts. So be sure you use the power injector that comes with the device. All right? All right. Now, the other thing I want to show you, I ran out of room recently on my video editing hard drive array. I've got an external rated 2 terabytes of setup from Otherworld Computing. It's Thunderbolt connected, so it's really fast. And but I filled it up, and so I needed a better solution. So I know you've seen these docks, okay? No problem. people have these. These docks are not so expensive anymore. But I finally found one that has a Thunderbolt connection on it. Now, that was a little hard to find. I mean, you can buy all day long. These are SATA or USB 3. And as far as I know, my laptop doesn't have a SATA connection, but it does have Thunderbolt connections. So got the Thunderbolt on it. Got some high-performance hard drives here. They're 3 terabytes each. They plug right in, and there's lights to tell you that they're reading or writing or plugged in, and love it. So now I'm using a new hard drive for every big project. We'll fill it up or come close to filling it up, and then pull it out and move on. If I need video from that project again, well, I just go find that hard drive and plug it in there. So that was a good solution. I had several people ask me about that. What brand was this thing? High Point Technologies. Could have nicer graphics, but it's okay. So there you go. Those are my tips. Hey, we're out of time. We've gone over stayed past our welcome. Chris Tobin, if folks need some consulting services from you on making this crazy IP stuff work, they'll find you at where?
Oh, support at ipcodex.com. That's where several folks have found me already. So support at ipcodex.com.
Good deal. Chris makes himself available, a consultant to the industry for audio, for video, and for other interesting projects. He is a really extraordinary engineer and thinks out of the box. Can solve your problem. Okay, and I'm with the folks at Telos. Thanks very much to Telos and to Lavo for sponsoring This Week in Radio Tech. Also, thanks to Suncast for being our producer this week while Andrew Zarian is out on a secret mission. And maybe he'll be back next week. Hey, thanks for joining us. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.